In this section, we're going to be talking about how to solve polynomial equations, right? How to solve polynomial equations. So when you're solving quadratic equations, right? Remember, factoring is extremely useful, right? When we're factoring, remember how, we learned how to factor trinomials, and then we also had some special cases. We had difference of squares. Remember difference of squares, where you have a squared minus b squared factors to a minus b, a plus b. And then remember, we also talked about a perfect square trinomial, right? Where that factors as like a minus b quantity squared, okay? Now, this is for quadratic functions, right? We use it for quadratic functions, but you can really use it for any difference of squares. There are some cubic polynomials that can also be factored using shortcuts or rules. And that is the sum of two cubes or the difference of two cubes. So let's take a look at how the sum of two cubes looks. You have a perfect cube and you have a perfect cube, right? This one, you have a plus in the middle. So the first one is a plus b. So basically you take the cube root, whatever sign is here, that's what sign goes there. And then it's a square minus ab plus b squared, okay? Then if you have a difference of cubes, again, you take the cube root. Because there is a minus here, you have a minus here, and then it's a squared plus ab plus b squared. So how do I remember this? You have to memorize that it's like a and b, and then a squared, ab, b squared. As far as the plus and the minus, here's how I remember it. Each of these cases has one negative, right? If this is positive, then the negative is used over there. Or if this is negative, you use the negative here, and then you're all out of negatives and the rest is positive. Does that make sense? So basically in both of them, only one of the terms is a minus or a negative. Okay, let's do some examples. So take a look here. I have the difference of cubes. 27x cubed is a cube, and so is 8y cubed. What are these the cubes of? So 27x cubed is really 3x cubed, right? Minus 2y cubed. So now what ends up happening is this thing inside is a, and this is b. So this is going to be a minus b, so 3x minus 2y, and then a squared, so 3x squared, plus 3x times 2y plus 2y squared. Okay? And then you have to simplify all of that. So this is 3x minus 2y, 9x squared, plus 6xy, plus 4y squared. All right? Questions? Okay, and so you see how it's the same as the pattern. So it's a minus b, and then it's a squared plus ab plus b squared. Okay? All right, let's do another one. So here, 64f cubed. Okay, that's like 4f to the power of 3. But what about the 25? Is that a perfect cube? No. So this is prime, right? Because of the 25. Okay? All right, here. Here we can first factor out a GCF. So what can we factor out? A 3x squared. So I get 8x cubed plus y cubed. Okay? So this is equal to 3x squared. Okay? All right, let's factor Okay, so the cube root of the first one, 2x plus y. Now, we still have a negative to use here. So next what I do is the square of the first one, 4x squared, minus multiply the 2xy, plus y squared. Right? So once you do this, then it's square, multiply, square. Okay? All right. Okay, let's do another one. Okay, here, anything we can factor out? 5y. So I get 5y, I'm sorry, just y cubed minus 64z cubed. So this is 5y. All right, so this is a minus. Take the cube roots and I get y minus 4z. So now square the first one plus multiply them, 4yz, plus square 16z squared. Okay? So you have to memorize this pattern. All right, here. Okay, so there's actually two ways to do this. You can either do this using difference of squares or a difference of cubes. We're going to do it using difference of cubes. So this is technically x squared cubed minus y squared cubed, right? So this factors as, okay, x squared minus y squared, and then square plus or minus? What do you guys think? Plus. Multiply them, x squared, y squared, plus y to the 4. Now, can I factor further? Sure can. X plus y, x minus y, x to the 4 plus x squared, y squared, plus y to the 4, and that's it. What is? The bottom, yeah, that is difference of squared at the last step. But in the beginning, we could have done x squared, y squared. So look at another way. Here's how we could have also done this. From here, you could have done difference of squares, because this is also x cubed plus y cubed, x cubed minus y cubed. Is that right? Huh? But now you can further factor each of these in the cubes. Okay? All right. So let's, well, you know what? Why don't we continue with this? See where that takes us. So how do you factor the first one? X plus y, x squared minus xy plus y squared. How do you factor the next one? X minus y, x squared plus xy plus y squared. So let's compare. Did we get the same? So this and this are the same as these. And then the rest you have to multiply out and you would get the same thing. Okay, you see how these are each x squared, but that's x to the 4, right? So once you multiply out, some things cancel, and then you get the exact same thing. Okay? All right. So here, let's just summarize all of the different ways to factor something. You can always factor out a GCF from any number of terms, right? Now, suppose you have two terms, a binomial. The special patterns are difference of two squares, sum of two cubes, difference of two cubes. If you have three terms, you can have perfect square trinomial or general trinomial. Or there is always the grouping option if you have 4 or more terms. All right? Okay, so why don't we take care of this one? So how many terms does this have? 4, which means how can we factor this? Grouping. Okay, so let's split it up here. From the left, I can factor out an a, so I get a squared plus 3y. From the right, I can factor out, oh, a plus 3y, thank you. I can factor out a y, so what do I get? A y squared. So what do I get? Ugh, sorry, what can I factor out from here? 2y squared. So I get a plus 3y. Now, you notice how we get the same thing here? Factor that out, which means just write it one time. And then what's left over? A plus 2y squared here. Okay? And then just see, is there anything else we can factor out? No, we're done. So this is factor by grouping. Oh, take a look at that one. That's definitely 4 or more, right? So let's split that down the middle. And so if this is given to you in like mixed order, it's kind of tricky. So it's not really going to happen. But so what can we factor out first? 6x. So I get 5a minus 4b plus c. What can I factor out from here? How about a minus y squared? So I get 5a minus 4b plus c. Oh boy, look at that. They're both the same. So I write these here. Right? And then what do I have left? Correct. Does that factor anymore? No. But what if, okay, I'm just going to change the problem here. What if after you do this, then let's say you get like 4x squared here, right? Now you can factor further, right? It would be 2x plus y, 2x minus y. But too bad, that's not what we got. That would have been a better problem. Maybe I can put that on the test. Okay, he jumped on board. Okay, so how are we going to factor this? 2 terms. Which one of those can we use? Sum of cubes. So x plus 6, x squared minus 12x plus 36. Ooh, did I do that right? It should be minus 6x plus 36 equal to 0. Okay, this gives me x equals negative 6. Okay? Here, that can't factor. Quadratic formula. Yeah, let's do it, guys. Come on. X equals negative b plus or minus the square root of what? B squared minus 4ac. Right, come on. Why did we learn it? So we can use it. We got to solve for x. Look, factor and solve. 6 plus or minus, what do we get here? The square root of negative 108. Fabulous. Over 2. Okay, guys, come on. So 108. 108 is 2 and 54, right? Which is 2 and 27, which is what? 3 and 9, 3 and 3. Okay, so finally, let's see what we have. X is 6 plus or minus. What comes out? 3 times 2. 6i root 3 all over 2. Okay? So each of these can factor with a 2. So I get x equals 3 plus or minus 3i root 3. So I have 3 different answers. 3 different answers. Welcome to Algebra 2 Honors. Yay! I keep promising you things will get more complex. Yeah. Because you can't solve it any other way. You could have, okay, so look. It says to factor, huh? Okay, so listen to me. I'm talking. Okay, listen. Listen. It says to factor and solve. Solve means find what x is equal to. So I factored. This is what I got. Okay, x is equal to negative 6. But what about here? I now need to solve that, right? And get what x is equal to. In order to solve any quadratic equation, my first go-to is factoring. So I ask myself, can I factor this? No. If you can't factor something, your options are quadratic formula or completing the square. So we could have also isolated this, completed the square, and solved. You would have gotten the same exact thing. Now, if this is not your cup of tea, then, you know, I don't know. This is Algebra 2 honors. Okay, so.
Are there only 2 answers?
There are 3 answers because negative 6 is 1, and this is 2 answers here. 3 plus 3i root 3, 3 minus 3i root 3. Okay, so quadratic form for higher degree polynomials. We know how to factor a quadratic trinomial, right? So for example, if I have x squared plus 5x plus 6, I know I can factor this like this. What makes me able to factor this? Here's what. So here I have a constant. Then I have a variable raised to an exponent. In this case, the exponent is 1. Then I have the same variable with an exponent that is 2 times 1, right? So constant, exponent, twice the exponent. That's what makes me able to factor like this. So we can increase the exponent and still factor in the same way. So instead of 2 and 1, I can have 4 and 2. I can have 6 and 3. I can have 8 and 4, and so on. Okay? Now, that's what we're talking about here. Take a look here, and it says to write the following in quadratic form if possible. So for example, look at what I have here. I have a constant, I have an exponent, then I have twice the exponent. I can totally write it in quadratic form. What does that mean to write in quadratic form? It's 2x cubed squared minus x cubed plus 9. This is quadratic form because I've got a constant, an exponent, and then the square of the exponent. I have a constant, a variable term, the square of the variable term. Okay? So here, it's 8x cubed squared plus 6x cubed plus 7. Okay? Now, here, this is another situation that is exactly identical because I have a constant, I have a variable exponent, then I have a variable with twice the exponent. So I can still factor in the same way. Yeah. Because we want to write it in quadratic form. Just like here, I had a variable with an exponent, then I had the same thing with twice the exponent squared. So here I have x, here I have x squared. That's what makes it quadratic form. Okay, so here, look, constant, exponent of 2, then twice the 2, exponent of 4. So I'm going to factor in the same way, but instead of x and x, I'm going to make it x squared and x squared in order to make it x to the 4. So the rest is the same. What 2 numbers multiply to 100 and add to negative 29? Negative 25 and negative 4. Oh, but look, I can go further. X plus 5, x minus 5, x plus 2, x minus 2 equal to 0. So here, x is plus or minus 5, x is plus or minus 2. Okay? Remember how we were talking about, I'll get you in 1 second. Remember how we were talking about degrees and x-intercepts? However many, whatever the degree is, that's up to how many zeros you can have. So this has a degree of 3. Sure enough, we found 3 solutions. This has a degree of 4. We found 4 solutions. Do you see how beautifully this works? Question, go.
You not like move the 25 and then make x squared equals 25.
Right, but if it says to factor and solve, then you have to factor completely and solve. Now, in this case, it doesn't really say to do that, but I wanted to show you the full factoring of it. Because it could also be that I give you this without the equal sign and I just say factor completely. Okay, but yes, you can do that as well. Okay, how can we factor this? 4 terms, grouping. So first, I factor out x to the 4, and I get x squared minus 9 minus, that's it, just a minus, x squared minus 9 equal to 0. Never drop that equal to 0. So the term that's the same is x squared minus 9. Let me write it over here. Okay, what terms remain?
X to the 4 minus 1.
Minus 1. Good. There's a 1 here, an imaginary 1 equal to 0. Now let's factor further. So this factors as x minus 3, x plus 3. How does the blue factor? X squared plus 1, x squared minus 1. But that turns into x plus 1, x minus 1. So finally I have x minus 3, x plus 3, x squared plus 1, and then x plus 1, x minus 1. Okay? So these give me x is plus or minus 3. This one, x squared plus 1 equal to 0. X squared equals negative 1. Take a square root. What's x equal to? Plus or minus I. And from here, what do I get? X is plus or minus 1. So how many total solutions did I get? 2, 4, 6. Because it's x to the 6. Do you see how cool this is? Right? 6 total solutions. 2 of them are imaginary, the rest are real. So if I were to graph this, how many times is it going to cross the x-axis? 4 times, because the other 2 are imaginary. Do you also notice, again, the imaginary solutions came in pairs? You can never get 3 imaginary solutions or 5. It's either 0, 2, or 4. Cool? Isn't that cute? How awesome is this? You guys should be way more excited about this than you are right now. Yes, absolutely. All right. This is the last thing you're learning this semester. How exciting. And the homework is due next time.